Howdy, this is TUBALCAIN again at your service. You know, I like to make comments, but I don't know what the heck YouTube is doing with their unholy alliance with Google, who actually owns them, but this business of Google Plus has me baffled, and apparently most everybody else as well. But I wish they would stop it and stop changing things and making improvements. They'll improve it to death. Well, that's off topic, but what I'm going to do today, I'm going to start a series of videos, and I don't know how many it'll take, but it'll be on building a little wobbler or oscillating engine. There's a lot of you out there that have machine shops or lathes and so on in your basement and are looking for a winter project or wondering what to do with the machine. And even if you're not crazy about steam engines and so on, as I am, still it gives you something to build that gives you great satisfaction, requires at least some precision, and you end up with a finished product. So this is what we're going to build, or one very similar to it, not exactly the same. But first let me show you a few things about oscillating engines. Several years ago I did a 10-part series called Building a Model Steam Engine, and you can go back and look at that, and that's also a wobbler, but it's much larger, perhaps 12 or 14 inches high, and many of you have seen that. But that's kind of what I'm going to do today, only on a smaller scale and without castings, because when I build something with castings, that excludes most of you in regards to what you can do in your shops. But prior to that, there's another series called Foundry Pattern Making Steam Engine Castings, where I make all the patterns for that one that I just spoke of, and I believe that's 5 parts. So go back and look at that if you want, and remember, you can find any and all of my videos by just plugging these words into the YouTube search. Also add TUBALCAIN, because I have the name TUBALCAIN in the title of every one of my videos. Also, regarding the valving, or how the valves work in these little wobbler engines, there is one video that I made some time ago, and I made a teaching aid that's all out of clear plastic and colored plastic, and it's called Steam Engine Wobblers, How the Valving Works, TUBALCAIN. Look that up, and that explains how the valving works in an engine with an oscillating cylinder. So go back and look at that, because I'm not going to talk too much about how the valves work other than in passing as I do the actual machining. The neat thing about these engines is they always run. If you take care in your machining and you have good alignment and everything, they always work. And they can be run on compressed air or steam, but the reality is, in your shop you'll probably be running them on air, as I am right now. And this is about 3 or 4 pounds of pressure right now. They do have quite a bit of vibration to them, and this is a single acting, and I'm going to explain what that means here in just a moment. I believe I probably could have used a slightly larger flywheel on here, although that is a lead flywheel. But there's always some experimentation when you're doing something like this, and I didn't work with plans at all. It's just off the cuff, but I'll make a set of plans if there's any interest in it, and show that in a video, dimensioned drawings. And they'll really run fast too. That's well, that's 10 pounds of pressure, but it really bounces around. A lot of reciprocating action there. I always like to run my engines at a slower speed. I just find it more fascinating that you can see the different parts. This is the inlet, and the other little brass tubing there is the outlet, and of course you can reverse the direction of rotation just by reversing the inlet here. You could also make a little valve that would do that if you want to be challenged. This is all made out of aluminum bar stock except for the flywheel. However, the base actually is a piece of magnesium, and it's magnesium simply because that's what I happen to have. No good reason. Now, as mentioned before, I'll turn that off. This is a single acting steam engine. That is, the air or steam pushes the piston down just in one direction, and it moves back up due to the momentum of the flywheel, the same as a gasoline engine. But there are double acting engines as well, and I'm going to show you a couple of samples here. The double acting, like most steam engines are double acting, the piston gets pushed and pulled, and there's a power stroke every half a revolution rather than one power stroke per revolution on these. Here are some other little wobblers that I made some time ago, and these were made with castings, and I think I have shown these in other videos, but I'll run them here in a second, but I want to talk about them real briefly. Again, here is a single acting, and you can see that the bottom of the cylinder is open. Matter of fact, when you crank it around, you can see the bottom of the piston. These are simpler to make because there's less parts, and there's less alignment you have to worry, and there's only one set of valves here on the top. Now, I made the same engine basically in a double acting, because you can see it's got a bottom here to the cylinder, and as far as the valving is concerned, here's the inlet, and then we have dual exhaust here, and the two inlets are hooked together by tubing. That could be done internally too with holes that are drilled. I like the double acting better. It's just they run a little smoother and slower. So let me run this double acting first. There we go, running silently, and that's only on about 2 pounds of air pressure. I've got a regulator over here in my right hand that I'm slowing it down, but at some point it will stall. But it runs quite slow. The valves are actually ports. You get to see a little bit more of that later on. Most of you know what I'm talking about. So that's a double acting. Piston being pushed down and then pushed back up. Now there's the single acting. She stalled. It didn't have quite enough air pressure. That's about 5 pounds. Needs a heavier base. I don't have the right size fittings here, so I got quite a bit of leakage right here. I've pushed a brass tube inside of a copper, and I can feel air leaking there. But that's the single acting, and this one also is a single acting, and that's enough now of these older ones that were made by castings as I start to talk about strictly the one that we're going to build. And the one that we're going to build may look just a little different than this, but this is the basis upon which I'm going. And we have a 1/2 inch bore, and we've got about 3/4 inch stroke. Notice I drilled an extra hole there so I could experiment with different stroke lengths. I just came from our local recyclers. I used to call them a junkyard, and I said, do you have any aluminum here, rounds and squares or whatnot, you know, make a little engine. And the man, oh, it's cold here, it's about 10 degrees, and it was slippery out there, and he went out and he dug through a barrel, and I bought all of this aluminum here for $4.20, and this is the material I will use. It's still cold. This is the material I will use for the cylinder, and I probably should buy a lot more. I think I'll go and buy a bunch more, because there was a 55-gallon drum full of this. These are cut-offs, I suppose, from a local machine shop. And here's some nice stock, round stock. I won't use all this for this project, but it's certainly something I like to have in stock. And that's about 1 3/8 diameter. This is 1 inch by 2 inch. And it still stinks like coolant. Reminds me of working in a factory. I also have quite a large selection of aluminum scrap in my aluminum box. So I guess we could call this a scrap box engine. Now for a base, rather than use 2 pieces like I have here, I'm going to use this casting which I had in stock. And that actually is so similar in size and dimensions of that, it's just really surprising. And you can modify these engines or beautify them or whatever you want to do, you know, rounding corners and beveling and, you know, giving it a little bit more oomph as far as what it looks like, a little more charm. This is pretty much straight bar stock, but it's simple. And if this is your first try at an engine, you know, don't waste time beautifying it when you can, until you get it running, or until your second or third one. Now this took me probably 6 hours to make in all. Not at one sitting. So this will be the upright, that's cast aluminum. I'm going to use a little bit larger flywheel than that, and it'll be out of bar stock like this. This is a little too big and a bigger hole than what I want to use. I'm going to use a 1/8 inch shaft. This is 1/4 inch. I've got a bunch of other flywheels here. These are from my stock lead flywheels in different sizes that I use on some engines, but that's way too large to use on this engine. But I do like the looks of a spoked flywheel as opposed to one that is just turned. And the flywheel needs to have some weight. Do not use aluminum. In order to make this lathe, you need a lathe and a drill press. It would be nice to have a milling machine, but it's not absolutely required. But I can't live without my Bridgeport. And then of course all the standard measuring and other tools that you would have in a small metal shop. So let's get started, because this is going to be a long video. I will not show every step, that isn't possible, but I'm going to show you most of the major steps. When I'm doing my model making, I like to use this brass rod and tubing. Comes in rounds and squares, and this is tubing here, and that's available at almost all hardware stores or building centers in the hobby section. And this tubing is made so that one piece will fit inside of another, so it's just beautiful for something like this. For instance, the main bearing you see there is brass tubing with a 1/8 ID, and that's an 1/8 inch shaft. It's brass also, but that's just brazing rod. Here's some more of that brass tubing. And this shaft here connecting to the cylinder is also 1/8 inch brass. This is 1/8 inch brass, and that's a piece of 3/16 brass. Now in this engine, I designed it to be headless. That is, this is a blind hole. Now the reason I do that is because it's one less part to make. Although working with a blind hole isn't necessarily easy. But when you get into heads, often small parts like this need to be, if you're going to fasten them with a screw, the screws are tiny, and there's a good chance as a beginner that you're going to break through the side of the castings and just get disgusted and quit. Now notice that on these engines you don't see any screws. And I have been greatly criticized because of this, but I use Loctite bearing compound to hold the head on here and here. I used it to hold the connecting rod pin onto the crank. Even this flywheel is held on with Loctite. Now you don't have to do that. And I have never had good comments on my using the Loctite. I don't know if people think it's just an easy way out or what. I do like it very much. If you make an error and you got to take it apart, your tiny little micro torch will heat it up and allow you to remove it. I don't know what grade of bearing compound I'm using because it is so dirty and old. I've had this forever, and there's still about an inch in here, and it's red in color, but you know, Loctite makes about 100 flavors. You know, when I was looking at this engine a moment ago, there's really only 3 threads. There's 2 here, tapped up into the vertical upright, but I won't even have that in this one because I'm using a casting, but I believe you'll have to make yours similar to this. This is about 3 inches square and 3/8 thick, just to give you an idea. And there's another thread right here where this knurled nut goes on, and that's a nut that I had in stock. I did not make that. So I had 1 thread to produce, and that was a 540 on the end of this brass rod. And it's kind of a relief to get away from those small threads. Now when you compare it to this engine, and this is one I did not build, but look at the number of threads here. You got 4 of them here. You've got on the lagging here 2 on the top and 2 on the bottom, and here we have beautifully spaced head bolts, and there's 6 of them, but these are probably number 4s or number 3s. That is a difficult thing for a beginner to deal with, and the same thing on the other end. That's why I'm trying to avoid this in this engine that we're going to build, because it'll simplify it so greatly. Same thing here. Look at the threads. 1, 2, 3, and everything has to line up. Now you need to learn how to do this sometime, but not on this simple one. And isn't this a beautiful engine with this ring gear that maintains parallel motion with the shaft? Always remains parallel to the base. I like looking at this. But there is a little tight spot right there. So there's just some very, very minor misalignment, which could only be like a couple thousandths of an inch one way or the other. I'm not sure where it's binding, but it does run fine. And I believe I have run this in one of my other videos. But that's why I'm telling you that I do not want to use threads on this. You certainly can make variations in what I'm going to show you and use threads if you're good at that. But when you get into those number 4s and number 5s and number 6 threads, it's very easy to break off a tap, you know, if you're not used to doing that. When I went to the junkyard, and by the way, I tipped that poor guy $1, said get some hot coffee. 2 guys were huddled around a kerosene heater in an abandoned building, and sold me this. Nice guys, but I thought, boy, on a winter day, and they were dressed with Carhartts too. But I went to the scrapyard to get some square tubing, 1 inch, or not tubing, solids, 1 inch by 1 inch by whatever, you know, and they didn't have any. But this is it was quite fortuitous that this is 1 inch thick and 8 inches long, and so I'm going to cut it off at about 3/4 because that's the width this way, and it's 1 inch here the other way. So this is just perfect stock, and it's cold rolled aluminum. So I'm going to lay that off and bandsaw it, and I'll take this over to the mill right now, and we'll square up the bottom, and I'm going to drill a couple holes in there and mount it temporarily on wood. Just some scrap wood for a working base, so this has a little stability when I'm working on it, and it doesn't keep falling over and annoying me. So that's what I'll do first. I'm at the Bridgeport Mill. Now if you haven't seen one of my other videos where I make this nut buddy, and this is used to loosen and then tap the drawbar on the milling machine, but I show you how to make one of these in 2 different versions. I call it a nut buddy. Quite handy. Brass on an old wrench. Okay, the work is held in the vise and it's up on a parallel, and I got a 3/4 inch end mill there, and all I'm going to do is very quickly square up the bottom. The dimension does not matter at all. like to take a very light cut, climb milling, for my finishing pass. It leaves a better finish on aluminum. I am climb milling. And there it is. Quite a nice finish, although it doesn't matter because this is going to be down, and there's some pitting there that will not come out because those are deep pits, and that's where the gate ran into the casting. Remember, the castings always have that taper or draft on them from the pattern that allowed it to be lifted out of the sand, and that's what I removed. I squared it up. This is a pretty good finish here. I don't believe I'm going to mill that, but that's where the cylinder will oscillate. And if it isn't smooth enough, or there's air leaks there later on, I'll either mill that or draw file that or belt sand it ever so lightly.